Assalamu alaikum dear students. Today we will study different BJT biasing schemes besides the voltage divider biasing we have studied so far for analysis and design of BJT based circuits, especially the BJT based amplifier circuits. We have analyzed an amplifier in which the first step was to find the load lines at the input side and at the output side and find the Q point VBE IC, VCE IC, right? And find what is the polarity of collector base junction and emitter base junction. And after finding these two things, we know in which mode the transistor is operating. Obviously, we have studied actually analyzed the amplifier circuits, so we would be knowing that we should be having base to emitter junction as forward biased and collector base junction as reverse biased. So in the analysis process, we have gone through these points first, right? So these are nothing but the biasing of a transistor for an application. For example, we have studied for amplifier. So we already have analyzed a biasing scheme which is called the voltage divider bias, in which we have used two resistors by which we have set the voltage at the base with respect to the emitter to have a base to emitter junction forward biased. Similarly, for that base voltage, we have set a collector potential by using a power supply and the resistor RC to have a reverse bias potential here to have effectively the mode of operation as active mode for amplifier application. And we have analyzed all these things for common emitter only, right? Because after biasing, we have applied the input AC signal at the base with respect to the emitter and collected the output at the collector with reference to the emitter. So in these lectures, we will introduce other biasing schemes besides the voltage divider biasing scheme. And we bias a transistor for a particular application, right? For example, here we bias this transistor so that an input AC signal can be amplified. So it means the parameters, currents and voltages here should be stable as soon as no AC signal is applied, right? So in this lecture, we will also consider the critical parameters by which we can make our biasing scheme stable. So we have also gone through a basic design methodology, right? It means not only analyzed, we have also gone through one or two examples to bias a transistor, right? We have found R1, R2, RC, and without RE application and with RE application, right? I did this for you without RE and I asked you guys to find or to bias a circuit with RE, right? So we have also designed the common amplifier amplifier circuits, right? And we know that once we have biased a transistor, right, it should be stable, right? But the Q point or these parameters should fluctuate or vibrate for an input AC signal to provide the output amplification, right? So it means Q point need to be vibrating for an injected AC signal, right? So for an injected AC signal at the base to emitter side, because we are talking about common emitter amplifier, right? So at the base with respect to the emitter, then part of this becomes the VBE. The Q point will fluctuate at the input load line, provide a fluctuation in the collector current, and that fluctuation in collector current will provide a fluctuation in the collector to emitter voltages, which is nothing but our output signal. So do we have other parameters, specification or considerations while biasing a transistor? Yes, the number one and the main thing is stability of the Q point against other parameters. Other means other than the injected AC signal. What are they? Temperature, right? It should not be varying with temperature. Otherwise, your Q point is not stable. So the output will think that this fluctuation is coming from an applied input AC signal. It cannot understand that this is nothing but because of some other fluctuations, or we can say these are noise. So we don't want noise signals, right? Variation in beta. For example, you have designed a transistor based amplifier, right? You set a transistor beta is equal to 300. You plug in the transistor and go on. And if this transistor burned out or maybe weird, then you can replace the transistor, right? So even you are replacing the transistor of the same model, but within the same model, during the manufacturing, we have variation in beta, right? So that variation in beta will destroy your design, right? So it will never be stable. And other parameters also, but we will study only about temperature and beta effects, right? So we will explore other biasing schemes or techniques other than voltage divider bias, right? And we will also see how voltage divider biasing scheme can also be made stable against these parameters, right? So let's start with the classical biasing using a single power supply, right? So we have studied already the voltage divider biasing scheme with only a single supply, right? And we already saw that the Thevenized version at the base side of this circuit is this one, right? So this is called voltage divider biasing, by which we are fixing the base to emitter voltage, right? By using this R1 and R2 about this VCC, we are fixing the base voltage with respect to the emitter. So we are making the base to emitter voltage fixed, right? So if the Thevenin's equivalent circuit of this one is this, right? So we can also use a single resistor with this VCC. Then we don't need to find R1 and R2 separately. We have to find just RV, right? But here we are actually fixing the IB. Obviously, for a fixed VBE, as in the previous circuit, for a fixed VBE, we must be having a IB, but we are fixing VBE ourselves, right? And here we are fixing the IB ourselves, right? By using this current limiting resistor. and then VBE would be for that IB, right? So this is the same classical biasing scheme using a single power supply, right? But here we are fixing IB ourselves, right? VBE would be taken itself, right, for that IB, because we know that base current, collector current to base current having a relation, beta relation, right? Same is the case that collector current is having a relation with the base to emitter voltage, right? So this is the classical biasing scheme using by fixing the IB, and here we can fix the bias current by using this formula, right? By writing a loop equation here, right? So VCC, IB, VBE, right? So IB is equal to, if we send RB towards the second side, right?